All right, here we go. Section 1.1. This is the first section for our class together. So here we go. Question to start off. I know you know the answer to this. It's going to seem like a way easier answer than it should be for the first question in algebra class. What feature makes something an equation? If you're looking at it, how do you know you're looking at an equation? There's an equal sign. Yes, wasn't that a remarkably, I know, it was too easy. You didn't think it was right. There's an equal sign. So for instance, what that means is this. If we see this right here, this object, 3x minus 7 is equal to 14. That's an equation. How do I know it's an equation? There's an equal sign right there. That means that there's two sides to this thing. So this is an equation. What we're going to see in equations is what you'll be told to do most of the time, and that's what we're going to focus on today. You're going to be asked to solve an equation. And in case you don't know what the word solve means you're going to find the value that creates a true statement. That's what solving is. You're going to find the number value that creates a true statement. That's what solving is. We're going to solve what's called linear equations today. We're going to come back. We're going to solve several different types of equations over the course of this semester. Now, when there's not an equal sign, so for instance, if I just leave off the right half of this and I have just 3x minus 7 with no equal sign, we'll see things like this over the course of our semester together as well. This is called an expression. You don't solve expressions. You can't. It's not an equation. Now, what we will learn to do is, depending on the type of expression, there might be a way that we can simplify it. We might be given a value and we can evaluate the expression. Evaluating is not the same thing as solving. Solving means that I am finding a value. If I evaluate something, I am given a value and I plug it in to see what the output is going to be. Okay, just trying to clue you into the differences. So what we're going to focus on today, again, hopefully the thing that you've seen before and that you're going to be like, okay, Perkster, I'm a little bored with this, but I feel confident that I can do it, is we're going to look at what's called a linear equation in one variable. In chapter 2, we're going to talk about linear equations in two variables and what we do with those. But for now, we're only going to have one letter involved in this. And every single linear equation that you're going to see in this class, in this first section, can be written in the following format. Okay, so a linear equation in one variable can be written in this form. We've got some number, any number, in front of an x or a y or j or whatever your favorite letter is, plus any number b is equal to any number c. And you saw that up here. We've got a 3 in front of the x, we've got a -7, and we've got a 14. Okay, that's a linear equation. This is just the general way of writing it. And what we're going to spend the next, however long, that clock doesn't work in this class, what we're going to spend the next 50 minutes or so doing is just solving a variety of linear equations so that you get experience with each of them. We're going to start with the most basic one, and we're going to work our way up to what will eventually be a little bit more complicated. So looking at example 1, this is my example, but you're going to help me with it. We've got x plus 5 is equal to -9. When I solve something, I always want to get the x, or whatever the letter is, by itself. What am I going to do to both sides of this to get the x by itself? Go ahead. I'm going to move the 5. How am I going to move it? Why did you pick subtraction? Perfect. It's the opposite, because there's addition. That's your clue. This is a plus 5. That means we're adding 5. So we always do the reverse process. So what I'm going to do is I'm going to subtract 5 from both sides. Now I'm going to ask you a favor. I'm asking you this favor because it's going to help me help you. When you take your test, I'm going to ask you to write your work down. And the reason I'm asking you to do this is because if you have a brain fart and you mess up the arithmetic here, if you've written down the step and I know you know what you're doing, I can give you partial credit. Okay? But if you just throw down an answer, I can't do that if you end up getting it wrong. Okay, so please show me the work. It'll say that in the instructions on the test. I'm not trying to be mean asking for work. I'm trying to help you and give you as much credit as I possibly can. Because again, It gives me no joy for people not to pass this class. Okay, so here we go. So now I'm subtracting 5. And so on the left side, the 5s cancel, and I'm left with x. On the right side, -9 and -5 is -14. That is the value that creates a true statement. You can always check. I don't always check just for time's sake in here. Now, one other thing you're going to do for me, again, I'm trying to prepare you for college algebra. Math is a language. I want you to learn to speak it a little bit. Okay, so what we're going to do is instead of leaving the solution like this, we're going to write it as a set. All of our solutions, whether it's an equation or an inequality throughout the semester, we're going to write as a set. So this is the set that contains -14, and that is my answer. So far, so good. Anybody got a question, a comment, or a concern for me? Then what I would like you to do is look on the right side. I want you to do exercise 1. This is the way I teach my class. I do an example, I get your input, then I have you do one so you can get the tactile experience of actually solving it yourself. And you can give me any feedback you need to. Yes. I sure do. Yes, you're doing exercise 1 right now. Okay, for exercise 1, we've got y minus 9 is 14. What step did I have to perform to solve this? Add 9. Why did you pick add 9? Because right now it's subtraction. Okay, I'm just trying to help you see so that when you get a test thrown in front of you in a couple weeks, you know exactly what you should be looking for. So we're going to add 9. On the left, the 9s cancel because we have a -1 and a +1. So we have y. 14 and 9 is 23. And my answer is the solution set with 23 in it. We still doing okay? All right, we're going to do another problem that's just as basic as we can have. So looking at example 2, before we do the solving, on the left side of this, I notice the -8, and then I don't have a sign between the -8 and the x. What operation does that mean is being performed there? Multiplication. So what's the reverse process of multiplying by -8? Dividing by what? Okay, if you said 8, you're close. We always want the x to be by itself. So if I just divide by 8 here, I have a -8 divided by 8. What does that leave? -1, -1x. So in order that there's just x, you always divide by the exact same thing that's there. So we'll divide by the -8. Because a -8 divided by a -8 is a +1x, or just x. You're welcome to write the 1. I don't care, but I don't because it's more proper in algebra to not write the 1. It's implied. 56 divided by -8 is -7. And there we go. There's my solution set. The set with a -7 in it. If you feel good about that, go to exercise 2 right next door. Same thing, just different numbers so that you get the experience of solving. And what did you do to both sides of this equation? Perfect. We're going to divide both sides by -4 because the opposite of multiplying by -4 is to divide by -4. So a negative divided by a negative is a +1x. A -32 divided by -4 is +8. And my answer is the solution set with an 8 in it. So we've each done an example of the absolute most basic linear equation. So now what we're going to do is we're just going to build up gradually so that hopefully we get enough experience that nothing is going to be intimidating for us. So the next one is example 3. I've got this linear equation. I've got 2x plus 7 is 25. Now here's our strategy. Before I can get the x all by itself, I've got to get the term with the x in it all by itself. It's a 2-step process. So what do you think step one is going to be? Not subtract the 2. I'm going to subtract the 7. The 2 is attached to the x by multiplying. We're going to take care of that second. Okay, so I'm going to subtract the 7. And again, the reason I'm doing this is before I can get the x by itself, I've got to get that whole term, that 2x by itself. That's my first step. So now I have 2x, the 7, the minus 7, those cancel. The 25 minus 7 leaves me 18. Your calculator can show you that. Don't be shy. Use your calculator. And then this is in general going to be our last step, like 99% of the time. I'm going to now, I've got 2x equals 18. We just did this problem right before. What am I going to do? Perfect. Well said. Excellent job. And so then I get x is equal to 18 divided by 2, or 9. And there's my solution set, the set with a 9 in it. If you have a question, ask it. If not, exercise 3, right next door. Same thing. All right, so I see some of you are done. I see some of you are still working. I try to cut the difference. Perfect. That tells me I'm right on time. I'm not, if you're still working, I'm not trying to shame you, make you feel like you should be done. We all work at different paces. I've just got to keep class moving. So keep working. We'll all catch up at the end. So what's the first thing I got to do here? Beautiful. Well said. Notice I'm doing the same thing every time. Once you get it, the algebra never changes. It's just a matter of figuring out what to do. So we've got 5x on the left, 21 and 4 is 25 on the right. I divide both sides by 5 because that seems to be where these equations are ending up. And I have the solution set with a 5 in it. I'm going to flip the page. Anybody got anything to bring up before I do that? All right. Again, we're gradually getting a little more complicated. And example 4 is the most complicated linear equation that I can give you. What makes this a little bit more difficult than the previous problem we just did? There's x's on both sides. Yes, there's one variable, but it's in 2 places. There's the x variable. Okay, so if you can get if you can get example 4, there's nothing else I can throw at you in a linear equation to be tricky. Now, what I do, Miss Hilliard, 9th grade, she demanded we do the same thing every time. So I'm like Pavlov's dog. I always put the x's on the left. If you put the x's on the right, that is great. Okay, there's nothing wrong with that. We will all end up at the same place. But I'm just letting you know I put the x's on the left just because that's how I was taught to do this. So what I'm going to do is I'm going to bring the 5x over to the left. How am I going to get this term, this 5x? What am I going to do to get it over to the left? I'm going to subtract. Yes, it's a plus 5x. So what I'm going to do is I'm going to subtract 5x. Now, if you will allow me, let me know if this is too complicated for you, and I can separate these. I've put all my x's on the left. I'm now going to get all my numbers on the right. So I got to bring this 6 over to the right. How am I going to do that? Yep, I'm going to subtract it. So notice we're just using that basic step that we did a couple examples ago, and we're doing it multiple times. So now on the left side of this problem, I've got 8x minus 5x, that is 3x. The 6's cancel because I moved the 6 over to the right side of the problem. My equal sign always stays right in the middle. The 5x's cancel because I brought the x's over to the left. And then negative 12 and negative 6 is perfect. You guys are doing great. And then last but not least, again, this is always our mop-up step right here. I'm going to divide both sides by that 3, and I get x is negative 6. That's what my calculator and your calculator would give us as the output. And so my solution set is the set with a negative 6 in it. We feel okay about that? All right, exercise 4 right next door. You go ahead and take that one through to the finish line. All right, I'm going to put the X's on the left. Again, if you put the X's on the right, we will end up at the same destination. So I'm going to put the X's on the left. I'm going to subtract the 7X to bring it over to the left. So subtract 7X. I'm going to move my numbers over to the right. So I'm going to subtract 1. So 9X minus 7X, that's 2 of them. The 1's cancel because I put the 1 over on the right side of this. The equal sign stays in the middle. The X's cancel because I move those to the left. And -9 and -1 is -10. Just as an aside, if it makes more sense to your brain and you're putting the X's over on the right, then what you're looking at right now is you have a positive 10 on this side and you have a -2X over on this side. That's fine. You're in the right place. And then once you divide and once I divide, we're going to have the same final answer. So I'm going to divide by 2. And we all should have X is equal to -5 in our solution set. Questions, comments, or concerns before we move on? All right, so we look at example 5, and now you're thinking, well, Perkster, you just lied to me because that equation looks more complicated than the previous one. Well, it will boil down. We can make this look exactly like the previous one. Okay, there's no other solving steps involved. Look at the left side of this. Is there anything I can do on the left side of this to make this look a little simpler? Combine like terms, excellent language. I appreciate the lingo, meaning I can combine the things that look the same. Now we're not moving anything across the side, so don't do opposites here. 4X minus 2X, since they're on the same side, I can just do the arithmetic. 4 minus 2 is 2X. And on the right side, is there anything that I can make simpler? Yep, the 4 and the 3. And so I have 6X, and then the 4 and the 3 is 7. Or you could have 7 plus 6X. The order of the terms is not important there. And lo and behold, look what happened. All I did was a little bit of arithmetic there. And now this equation is the same form as the equations we just did. Okay, they'll all boil down to some form of this right here. So I'm going to put my X's on the left. I'm going to put my numbers on the right. I'm going to divide. I'm going to be done. Same thing every time. So I'm going to subtract 6X to put my X's on the left. I'm going to add 5 to put my numbers on the right. (2x minus 6x is -4 of them. The 5's cancel because I put the numbers over on the right side of this. My equal sign stays in the middle. The 6x's cancel because I put all the x's on the left. And 7 plus 5 is 12. When I divide by -4, we should all end up with an x value of -3. -3 is the number that when I plug it back in would create a true statement. If that seems reasonable to you, exercise 5A in the right column. If you have a question, raise your hand. Let me do my best to help you out. All right, just splitting the difference again. So if you're still working, keep working. If you're still working, it's not saying there's anything wrong with you. We all work at different paces. So here goes. On the left side of this, I've got like terms 4x and 8x. That gives me 12x's plus 25. If you get something different, let's talk about it. On the right side of this, I've got 17x, and then -9 and -1 is -10. You could have those terms in a different order. If you have -10 plus 17x, that's totally 100% fine. I'm now going to put my x's on the left, my numbers on the right, as I've been doing. I try to do the same thing every time so that as I'm learning this, it's going into my brain, doing the same thing every time. So 12 minus 17 is -5x. The 25s cancel because I put all my numbers on the right. The equal sign in the middle. The 17s cancel because I put all of my x's on the left. And -10, -25, -35. And when I divide, we all end up with 7. That's what my calculator would tell me. I just have us repeat problems, and you're going to do homework and you're like, why, Perkster, why are you making me do this? Anything you do that you're going to learn, you learn by repeating. So whether it's a sport or whether it's music or whether it's art or whether it's math or anything else, you learn, you lock it into your long-term memory by repeating it. So we're just going to keep doing problems. So hopefully it creates some remembrance that'll get you to doing homework, and then you'll lock it in a long-term memory. So do exercise 5B right below that, please. It's the same sort of thing. All right, so let's give this a try. Let's see how we go, because I do have a reason for picking these particular numbers. Okay, and it was the question that was just asked of me, which was a great question. So on the left side of this, there's no like terms, so that's 5x plus 11. The right side has all the like terms this time, so I've got 2x minus 4x, that's -2x. I've got 13 minus 2, that's plus 11. So far, are we so good? We doing all right? Okay, I'm going to do the same thing. X is on the left, numbers on the right. So when I do x's on the left, I add 2x. And when I do numbers on the right, I subtract 11. So 5x plus 2x, that's 7x. The 11s cancel because I moved all the numbers to the right. The 2x's cancel because I put my x's on the left. But what happens to the numbers on the right? What's going on there? They cancel out. So what is the value? 0. Yeah, 0 is a number. It's usually the amount of money I have in my wallet. Okay, so it's a number. And now when I divide both sides by 7, if you have 0 of something and you're going to divide it into 7 parts, how big is each of the parts? 0. Yeah, if you have $0 and you're going to give an equal amount to each of your 7 friends, you're giving them all 0. Okay, 0 is a number. It's great. So my solution set is the set with 0 in it. Sometimes students, and this is common, that's why I pick this problem, students want to say undefined there because there's a 0 or there's nothing on the right side. We'll talk about it. It'll be the last problem we do. When is that the answer that you want to write? Okay, so keep going. Example 6. I'm just trying to show you all the different looks that you're going to see so that there's no surprises in your life when you do your homework or your quiz or whatever. What is the novel situation to example 6 right here? What's different about this one than the previous ones? Parentheses. Yeah, does anyone remember the name of the property that I can use to get rid of those parentheses right there? It's called a distributive property. If you didn't remember the name, that's okay. But if you knew what to do, that's great. So I'm going to take that 2 and I'm going to multiply by each thing in the parentheses. That's called distributing. So 2 times x is 2x. 2 times -5 is -10. Am I going to multiply the 2 times the 3x? Why not? It's not in the parentheses. Yes, great. Good call. And then I have x plus 6 on the other side. Fantastic. So then 2x plus 3x, that is 5x. Those are my like terms in this problem. So you can see there's situations from other problems. This is all simplifying. We haven't solved anything yet. We've just made this look prettier. And now at this point, there's my most complicated linear equation that I can give you. I'm going to put the x's on the left, the numbers on the right. So here goes. X is on the left by subtracting. Numbers on the right by adding 10. 5x minus x is 4 of them, 4 x's. The 10s cancel because I put all of my numbers on the right. The equal sign stays in the middle. The x's cancel because I put all of the x's on the left. And then 6 plus 10 is 16. And last but not least, our same step that we repeat every time, I divide, and 16 divided by 4 is 4, and there's my solution set. Any problems or issues that you're having? All right, well, exercise 6A right next door. Please do that one. It's the same sort of thing, just slightly different numbers for you. And I'm going to get started. If you're working, keep working. Don't let me distract you. And we'll check answers at the end. And if we got anything we need to talk about, we'll talk about it. So I'm going to distribute. So 5 times x is 5x. 5 times -4 is -20. The 12 is not in parentheses, so I'm just going to write down -12. That's going to be a like term in just a moment. And then I have 3 minus 2x on the other side. Collecting my like terms, -20, -12, that's -32. And now I'm going to, once again, put all my x's on the left, all my numbers on the right. To get this -2x over to the left, I'm going to add it. To get this -32 over to the right, I'm going to add it. Five x plus 2x, that's 7 of them. The 32s cancel. 3 and 32 is 35, and the 2x's cancel. Step that makes us smile because it means we're done with the problem is to divide by 7, and I get x is 5, which then becomes my solution set, the set that contains 5. If you got a question, please raise your hand, ask it. There's no bad questions here. If you're feeling okay, go to the next page. Exercise 6B is just another one of the same. I do have a point to this problem, a reason I've picked this one, and we'll see how you do. Okay, on the left side of this, I need to distribute. If you're still working, pause for just 1 minute. What number am I going to distribute through the parentheses over here? Perfect. I love all those voices. If you made the following mistake, it's okay. Don't beat yourself up. It's common. That's why I picked this problem. Sometimes students say, oh, 2 minus 3 is -1, but that violates the order of operations. You have to multiply before you can subtract. Okay, so all of you who said -3, that was 100% great. Okay, so if you're still working, then keep working. I'm going to do that. So this 2 will wait for just a minute. Then the -3 times the 2 is -6. The -3 times the 6x is -18x. On the other side, 4 times x is 4x. 4 times 1 is 4, and then plus 36. And let me just reiterate, if you did make that mistake, don't beat yourself up. Mistakes are opportunities to learn. Okay, so mistakes can be good things if you let them be. All right, so we'll keep going. We're going to collect some like terms. 2 minus 6, -4. And then on the other side, I have 4x, and then 4 and 36 is 40. And now we're in the routine of it. Hopefully you know what to expect. I'm going to put the x's on the left, the numbers on the right, divide. It's every time. So subtract the 4x. I'm going to get this -4 over to the right by adding. And -18 and -4 is -22x. And then 40 plus 4 is 44. And we see that we're going to get this gratifying answer when I divide both sides, that x is -2. That's what my calculator would tell me. And that becomes my solution set. I'm still doing okay. All right. And this is the point now. I know for many of you, your blood pressure is about to go up. Your heart's going to start to race a little bit. Okay, so I'm hoping that we can make this go smooth and we're not too afraid. Example 7. What's in example 7 that we hate? Fractions. Yes. Oh no, fractions. So here's what I want to do. I know you want to do. We want a strategy so that I don't have to deal with the fractions. So here's what we're going to do. And you've probably heard this before. And so I'm not telling you anything that's new and unique. But what we're going to do in example 7 is we are going to go through a process called clearing the fractions. We're going to clear the fractions. I'm just going to write this right above the problem. What my desire is I want to create an equation that means the same thing, but has no fractions. Okay, that's going to be a little easier to look at. And the way we do this, the way we approach this idea of clearing the fractions is we multiply every term by the, I'm going to put in parentheses, the least common denominator. Or the least common multiple, they're the same thing. The reason I've put the least in parentheses is because a little mathematical secret, you can use any common multiple or any common denominator. You'll end up in the same place. I just like to use the least because the numbers will stay smaller. Okay. Now, looking at this, I have my two denominators. I've got the denominator 6. I got the denominator 3. What is the smallest number that is a multiple of both 6 and 3? Okay. So 6 is going to be the right answer. I heard 2, I heard 3. Okay. 2 and 3 are factors of 6. They are numbers that divide into the 6. So that's not quite what I'm asking. I want to show you something. I'm going to flip well, I don't have my pencil. After I do this problem, when I can go back and mess it up, I want to show you how you know there's a clue that 3 or 2 would not be the right number to use. The problem will tell you that that's not the way to go. Now, in case it's been a while since you found any common denominators and things like that, if you need a video to show you the proper math way to do it, send me an email. I got a link for like a 5-minute video I made to do that. But here is a strategy that will work for most all the problems. In fact, it works for all problems. It can just be inconvenient for some. The listing method. And here's what we're going to do. This is my example of the listing method. We're going to find the least common denominator, the LCD, between 6 and 10. So all the listing method, you're doing exactly what it says. I'm just going to create a list for each number of multiples. And then I'm going to stop when I find the first one that is in both lists. So for 6 times 1, what's 6 times 1? Yes, that gives us confidence, right? 6 times 1 is 6. 6 times 2 is 12. And now I'm listing. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. I'm going to stop there because I can always go and add more to my list. Now I'm going to do the same thing for 10, and you stop me now if you see something that's shared in both lists. So 10 times 1 is 10. 10 times 2, 20. 10 times 3, there it is. That's the least common multiple or the least common denominator between those two numbers. So that is the most straightforward way to find the least common multiple. Okay. Now, the only time that would be inconvenient is if you got some weird numbers. Okay. But most of the problems, if not all, that you're going to do, the numbers should be very straightforward. Okay. So that's, I like to keep this class nice and straightforward. So now, example 7, with that knowledge, we've already had the answer told to us. What is the least common denominator of those two numbers, 6 and 3? It is 6. And again, if you would just multiply and said 6 times 3 is 18, that'll work too. Okay, so I'm going to use 6, and here's what I'm going to do. I'm going to take 6, and I'm going to multiply it by each term. So I'm going to put a 6 over 1 right here. I'm going to put a 6 over 1 right here. And I know the other side is not a fraction, but you can't mess up the equation and keep it out of balance. So you've got to multiply by a 6 over on the other side as well. And here's how you know you've picked the right number. Anything with a fraction, the fraction should go away. So here, what happens between these 6? What's 6 divided by 6? What happens? They cancel. 6 divided by 6. And what's left when I cancel those two 6s? X plus 7. No more fraction. Yeehaw. Good. I didn't want it around anymore. The next fraction. How many times does 3 go into 6? Twice. Again, there, my denominator is gone. And now what I'm going to do with that 2 that's left, I'm going to multiply it by what was already there, the 2x minus 8. So 2 times 2x is 4x. 2 times negative 8 is negative 16. And then negative 4 times 6 is negative 24. And again, no surprises now. You see something that you've done a dozen times already. Okay, so getting rid of the fractions, I understand that's difficult. We don't like fractions. Trying to help you get around the fractions here. And so now let me just finish the rest of this pretty quick, and then you can do exercise 7a. So x plus 4x is 5 of them. 7 minus 16 is negative 9. I'm going to add that 9 to both sides, put all of my numbers on the right. And I've got 5x is equal to negative 24 plus 9 is negative 15. And when I divide, always the last step, very gratifying, I get negative 3. And there's my solution set, the set with a negative 3 in it. So here's what I would like you to do. I'm going to give you 20 seconds. Exercise 7a. I just in the margin of your paper, just write down real quick what you think the common denominator is. Don't shout it out yet. Write it down, and then we will compare notes. What did you write down? What's the common multiple or the common denominator between 4 and 8? 8. Yes, well done. Okay, so now what I want you to do, I'm going to write this down. I'm going to give you like 90 seconds. I want you to multiply each of the 3 terms here by 8 and then see what's left over. And if you have time, go ahead and take the problem to the finish line. All right, so I'm going to get started on the clearing of the fractions. If you were able to make it to the finish line, that's good. So here we go. The first fraction, 4 goes into 8 and leaves me 2. So now I take that 2 and I multiply it by what's already there. So the 2 times the x becomes 2x. The 2 times -4 is -8. The next fraction, 8 and 8, they cancel each other out. So all that's left now is the top of that fraction. So plus 2x plus 3. Are you tracking with me on this? I know it can be a little complicated. On the other side, don't forget to multiply that by 8. 5 times 8 is 40. I'm going to finish this up, and then what I'm going to ask you to do on the next problem, just to save ourselves a little time, because we got 14 minutes left, I'm just going to have you clear the fractions on 7b. Okay, so here we go. 2x plus 2x is 4x. -8 plus 3 is -5. I'm going to add the 5 to both sides. I've run out of room, so I'm just going to move over here to the right a little bit. So I got 4x is equal to 45, and I divide by 4. And don't worry that you get a fraction. Fractions are numbers too. Okay, I'm just going to leave it as a reduced fraction. If you want to write that as 11.25, that's fine. Just make sure in my math lab, when you're doing your problem, you pay attention to how they ask for the answer, because I don't want you to end up unintentionally having them mark a problem incomplete because you didn't put the answer in properly. All right, I'm going to leave that right there. What I would like you to do, 7b, identify the common denominator, clear the fractions. And that's as far as I'm going to take the problem, just for time's sake. What's the common denominator? 4. If you used 8, if you used 16, any of those will work just fine. I just use the least to keep the numbers at a minimum. So I'm going to multiply everything by 4. The first fraction, 2 goes into 4 twice. So that leaves me a 2. So 2 times x is 2x. 2 times 1 is 2. The next one, 4 and 4 cancel. So that leaves me just the x plus 3 in the numerator. And then the next one, 2 goes into 4 twice. So 2 times 1 is 2. If you want to finish this up later when you get home, the answer is -1. That's your solution set. You can double check. One more example of this, just to show you all the variety of different things you might see in your homework. 7c, instead of fractions, we've got decimals. Again, decimals are just inconvenient to work with. We'd rather just work with numbers. So anyone have a suggestion on what I might multiply each of these 3 terms by in order to get rid of the decimals? Why'd you pick 100? Yes, notice each of these has 2 decimal places. It's 0.08, it's 0.12, 0.03. So I need to multiply by 2 powers of 10 to move the decimal 2 places. That's 100. If there were 3 decimal places, you would multiply by 1,000. If there's 1 decimal place, you would multiply by 10. Yes, okay, just the number of hops you got to move the decimal. So on this one, we would multiply by 100 on each of these. And again, once you do that, it turns into a pretty timid problem. We've done so many of these now. 100 times 0.08, your calculator will tell you that that's 8x. Minus 100 times 0.12 is 12 in parentheses x minus 4. Equals 100 times 0.03 is 3 and in parentheses x minus 5. And then you could go do that problem and and go to the finish line. From there, it's not the worst problem. And if you want to do that later, the solution set is going to be 9 on that one. Give you a little practice to see how your short-term memory is working. All right, you're just about done with me for the day. You're doing good. I appreciate your endurance. Thank you so much. Before we turn the page, I want to point out one thing. Every problem we have done, okay, let me just, exercise 7C. Every problem we have done has been called a conditional equation. And you might be thinking, well, why is that called a conditional equation? And that's a great question if you were wondering. The reason is that number, the 9 that I told you is the answer, that number is the condition that makes a true statement. That's why it's called a conditional equation. That equation is not true for every number you plug in. It's only true under the condition that I plug in the value 9. Now we're going to flip the page. We're just about done. So at the top of the page, exercise 8A is a really super straightforward equation. I'm not even going to ask you to solve it on your own. We're just going to do this together because what I want to point out is the conclusion that we need to come to on this. Everything we've done up till now is a conditional equation. Each of these is a different type of equation. So for instance, on exercise 8A, I got 5x minus 15 on the left. On the right, when I distribute, 5 times x is 5x. 5 times -4 is -20. I'm going to put my x's on the left, my numbers on the right, like we've done 36 times already. So I'm going to subtract 5x to get all my x's on the left. And here's where I notice something interesting happens. When I go to put all of my x's on the left, what happens to the x's on both the left and the right? They cancel out. There's no more variables left. So I'm not going to worry about moving the number now that I see that. What I'm left with is I've got -15 on the left, and I've got -20 on the right. Is -15, is that equal to -20? Is that a true statement? No. Okay. And there's no variables to fill in any blanks to make it true. So this statement right here, if somebody comes up to you and says, hey, -15 equals -20, you'd be like, no, that is never true. And what this type of equation is called, it's called a contradiction. And since this equation is never true, what that means is there's no value of x. You can sit here all day and pick values of x. You will never pick a value of x that makes both sides the same. It's never true. And so the solution to this is that there is no solution. And the way we write that mathematically, because we're writing all of our answers as sets, is you would just write as an empty set. So I just use two squigglies with nothing in between it. I know many of you come here with prior knowledge and you had an instructor probably that said another way you can write that is using the null symbol. The null symbol is like an olive with a toothpick through it. That also means the empty set. They mean the same thing. What I would caution you to do, because if I see this, I know you know what you're talking about. You're just communicating it wrongly, is don't use both. More is not better. If you do this, is that set empty anymore? No, it's a set with a null set in it. And I majored in set theory. I'm sure you didn't realize that was a thing. That means something. So that has a completely different mathematical meaning in the language. So just avoid that. Pick one or the other, forget the other, and go with it. All right, last problem. Same thing, or something similar is going to happen here. So we see this problem, we're like, oh, cool, distributing. I love to distribute. It's one of my favorite things mathematically to do. So let's do it. 9x, -3 times x is -3x. -3 times 4 is -12. On the other side, 6 times x is 6x. 6 times -2 is -12. Great, I love to distribute. Collecting like terms is my second favorite thing to do. So 9x minus 3x is 6x minus 12 and 6x minus 12. Again, at this point, you probably see what's going on, but I'm going to take it one more step just to make it crystal clear. I'm going to put all my x's on the left like we just did a minute ago. So I'm going to subtract 6x. And once again, we see that the x's on both sides cancel, but my conclusion is going to be different this time. Because I have a -12 on the left, and I have a -12 on the right. Is -12 equal to -12? Yes, those are the same thing. And so this means that this is always true. No matter what value you put in, if you spent the rest of your day, because maybe you were bored and you needed something to do, plugging in values of x up here, any value you pick is going to make a true statement. It's always true because -12 equals -12. What this is called mathematically is called an identity. Identity is short for identical. And your answer for this is, since any value is going to make that true, the solution is all real numbers. Now, when we come back on Wednesday, I'm going to teach you how to write all real numbers mathematically. But for now, for this section, you can just type out all real numbers and you will be good to go. All right.